All right, welcome back, Math 20-3. Today's lesson is a continuation of chapter 6.2. Last lesson we discussed and solved some question about simple interest. Simple interest was an interest where if you invest some amount of money or if you borrow some amount of money from bank or any other institution, you get how much percentage out of that in certain term, like it can be 1 year, 2 year, 3 year, or it can be monthly, something like that. But it's generally yearly situation in real life too. But in any case, with the certain term or period of time of owning money or investing money, that term multiplied by the rate, which is how much percentage out of original amount, which is known as principal, and by combine and multiply by our interest rate with the principal, IPR, we basically get how much we owe to the bank if you borrow, or how much we will get as an additional money by investing, which is again to the bank. Like GIC is a good example, something like that. So we're talking about that simple interest. Simple interest, like the word suggests, it doesn't alter. Whatever the percentage value, it's still carved on stone. Like imagine you owe 1.2% of as an interest rate, that doesn't change for a certain amount of year. We sometimes call this closed investment because the percentage does not alter. What we're learning today is compound interest. So let's first talk about what's a compound interest first. Compound interest is basically interest calculated on the principal. Like what I mentioned, this is original money that you borrow or you invest, whatever the situation. Interest calculated on the principal plus interest earned in prior compound periods. So compound interest, the important difference between simple interest versus compounding interest term play a huge role because you get plus interest that is, or I like to say, it's a type of interest that yes is based on the principal original money, however you get additional, that additional value is plus any interest previously earned. So for example, if you invest 2 year period, whatever the amount that you gain from the first year, you can have additional interest. So it is a more complex formula, as you may already learn from this definition, I like to say. If you wanna learn a little bit more about page 293, talk about a little bit more. And of course, this compounding period, it's basically term. It's time between calculation of interest. And when it comes to compounding period, they have different type of compounding period, which is, for example, semi-annually or semi-annually. Or you may see the word like quarterly. When you see semi-annually, this is, of course, like every 6 months situation. Like a year is 12 months, right? So if you divide it by 2, that's every half year. When it comes to quarter, it's more like 1/4 or 25% of the whole year, which is 3 months, because 3 times 4 is basically 12 months. So you may notice that even if it's a year, we're not talking about a long time year as its term. We are basically breaking the year into several. You may also have monthly situation. If it's monthly, that's like every 1 month in a year, which is technically 12 months. Rare cases, you may see daily situation. If it's daily, like that's like 365 days, of course, because it's per day and in a year, right? So we have these special compounding period. So you may wonder, it is quite different. It actually have more number as a variable, if you will. Let's talk about formula. So how can we calculate this complex compound interest where even if you're investing for a full year, it divide into quarterly, let's say 4 different pieces, then whatever that money that I earn in the first month will be affected by second month and third month and fourth month, something like that as total. This is a formula. The difference between simple interest to compound interest is simple interest start with I is equal to PRT. So I is the main variable, or generally the number that you figure out. But in this case, A, which is our total amount that you get in addition to principal, can be calculated as one step. So sometimes people like this better because it's total calculation in one step. Principal plus interest A is equal to P bracket open 1 plus R over N and then bracket close, then exponent N T. You do not need to know how this formula is coming from, but you need to know what each of the variable letter stand for. P for principal, and R, small case r, represent annual interest. But make sure that it is in decimal. Most of the time, interest is shown as a percentage, but you have to convert percentage into decimal. Some people do fraction, but you're gonna use calculator, so decimal should work. N represent the special term that we learned, compounding period. And this compounding periods depends on what type you're dealing with. It is semi-annually, quarterly, monthly, daily. The calculation will be different. T represent term. And when I say term, it is total period. So how much in total that you are investing or you are borrowing, like student loans, something like that. So let's do one example. It is example located on workbook page, what is this page? 294. There are two parts of the question. Let's do A first, of course. Calculate the interest you would earn on $1,000 deposit in an account that pays 4% interest per annum, compounded annually if you left it for 2 years. So we have a lot of things going on. The very first step that you want to do is write down any clue that you have and list it. So I have principal that is given. That is basically $1,000. That's original amount that is deposited. Interest rate is given, which is basically your R. However, Or you may want to convert it into decimal. So instead of 4%, it's 4 divided by 100, which is 0.04. Have that in your mind. We also have total term that is given. It says if you left it for 2 years. So you may notice that I am including a unit too, just because unit is important to understand whether it's monthly, yearly, daily. It's good idea to understand. And the reason that I'm doing it is because N is also given. Although the question doesn't necessarily say quarterly, monthly, this is a situation where it says annuum, which is, it means yearly. So N is like 1 year because of the word yearly. I believe the question says annually, to be fair. So we have all of these clues given. Now our next step, copy the formula. A is equal to P1 plus R over N and NT. Then second step, substitute 1000, bracket open, 1 plus 0.04 over 1, which is like 0.04, and then 1 times 2. I generally like to simplify. 1000 multiply 0.04 over 1 is just 1. I'm sorry, it's just 0.04. So it's 1 plus that is 1.04. 2 times 1 is basically square. So now, take out your calculator. We're going to punch the number in. 1.04 to the power of 2. That gave me that. And I did this one first because bad math, if you guys remember. Exponent, you need to do before multiplication, right? Times by 1000. Gives me 1081.60, and that is how much total money that we will have. If you earn compound interest, your investment will be eventually worth 1081.60. And if you think about interest amount that you earn from the principal, you just minus 1000. So you technically earn 81.60 as an interest rate. Now, B. B question asks you to compare simple interest rate and what we did in part A, compound interest rate. So what you need to do at this time is, when we try to do simple interest, I know that, how can I say? I know that the total term is 2 years, but it is good idea that you need to calculate the simple interest situation with 2 years directly in there. So how can I say? The annually N is disappear. I'm gonna do writing information first. R 4 over 100, which is 0.04, and T 2 year, and out of the picture. So annually, that part, take it out of your picture. Some people rarely put T is equal to 1 year just because of yearly. But remember, simple interest, you are talking about, how can I say, the total time only. I'm going to put that. All right. Now, it's a two-step. I is equal to PRT, this part first. So P 1000, 0.04 times by 2, calculator time, 1000 times 0.04 times by 2 gives me $80. Now that's not final answer because when it comes to simple interest, you actually need to add principal amount with I. So it's a 1,080 amount. If I compare my compound interest situation, that was just gonna pick the previous answer, 1,081, 60. If you compare simple interest versus compound interest is larger. Some people may say, Mr. Kim, it's just $1.60 difference. So I may just choose my simple interest situation. I mean, in the end, it's your choice. But if you think about investing a lot of money, then it is a good idea to basically include the whole compound interest as your basic follow-up. Because the thing is, simple interest with small amount of money, yeah, it's just $1.60 difference. But what if you're investing $1 million? Do you know what I mean? Then the whole thing changed quite a bit. Let's do one more example. Example number 3, that you can find it on page 297. Now we're thinking about a little bit tougher example. We need to calculate 3 different scenarios. I'm gonna read the situation first. Calculate the final value of an investment. Calculate the final value of a deposit of $1,000 invested at a rate of 2.80 per annum for 4 years with the following compounding periods. So, and A is semi-annually, B is quarterly, C is monthly. So let's go through everything at once actually, because some of the clue repeats, like P, that's $1,000. Investment rate, R, which is 2.80. So if you divide it by 100, 0.0280. That's your compound rate per annum for total term 4 years. Now I'm gonna emphasize this term 4 years because the thing is, everything is calculated as year situation. So when you talk about quarterly and monthly, it's good idea to talk about the N differently. Now, gonna solve A in the left side, B in the middle side, C at the last side over there. So, here's the thing. One is semi-annually, and quarterly, and monthly. Now, let's think about it. N represent our compound periods, but N is specifically referring about number of compounding periods. That means how much time in this 4 years are we having the number of, how can I say, the number of periods is repeating every year. So if it's semi-annually, ladies and gentlemen, I want you to consider N is equal to 2 if the T is years, because semi-annually means every year you're gonna check twice, and next year twice again, third year twice, something like that. If it's quarterly situation, N is equal to 4, you check like seasons, spring, summer, fall, winter, that's 4 for 1 year. Next year, spring, summer, fall, winter, 4 different check time. Monthly is N is equal to 12. Basically, you are checking January at the end, check. February at the end, check. March at the end, check. So you got the idea. So here's what you need to do. Everything follow the same formula, except, well, N is the only thing that is different. Principal amount start with 1,000. 1 plus R value is 0.0280 divided by n for this is 2, and exponent is 2 times 4. If I look at my quarterly situation, 1,000, principal doesn't change. 1 plus 0.0280, that part also doesn't change, but n is equal to 4. And my exponent changed because it's 4 times 4. Monthly, 1,000, 1 plus 0.0280 divided by 12 at this situation, and the exponent 12 times 4. Let's simplify things a little bit. I'm gonna now solve semi-annually first. 1,000 and 1 plus 0.0280 divided by 2 is basically 0.014. 4 times 2, that's 8. 1,000 is 1.014 to the power of 8. 1.014 to the power of 8 equal to that number multiplied by 1,000 gives me 1,117.64 as my total value after the deposit. B, do the same thing, except I am getting rid of, unnecessary fraction to make my life a little easier. I'm using calculator too. You don't need to do mental math all the time. $1,118.08 0.0280 divided by 12. Oof, for this one, it seems like it's not simplified. So I can just simplify the top number. Let's actually do the last one together using calculator because it's tricky. 0.0280 divided by 12 is equal to that Gongshou number plus 1. I'm doing this part first. And then to the power of 48, that is equivalent to that number, that multiplied by 1,000. Then we have 1,118.37. Let me quickly double check. Seems like for some reason, if you look at work booklet, the work booklet answer is wrong. Just because it says 12 times 4, but for some reason, the workbook added up. So, of course, that's no. 12 multiplied by 4 is 48. So, this should be the right one. So, in this case, as you may notice, as I have more number of n, so compared to semi-annually, quarterly is more. And compared to quarterly to monthly, monthly is more. You may notice the amount that you earn get larger for more periods, more compounding periods, because the previous time before that check, which is 4 check, 12 check, those kind of things, affect and become additional moolah to you. However, again, it is important to understand that monthly is not always the best too. And that's where you need to look at different type of financial institution, because some of them have really good interest carbon stone from this period to that period, but some of them are open. During this COVID-19 time, open type of how can I say interest investment may not be the best because the world global economy, we're not doing well. The gas price going down because not a lot of consumption is happening. So there are many different type of reason why. Some of them needs to be, how can I say, basically you need to do calculation, meet your financial advisor, and talk things through. That's my advice. If you actually want to do investment in future, which I highly recommend, it's not a bad way. Okay. I believe right now 26. I believe that is a good place to stop for today. We did compound interest, and we also did a compound interest in different n value. So your homework, I want you to do workbook page 296 and workbook page 298. I want you to give it a shot.